I'm going to use ArcGIS Pro for intelligence to identify the links between people confirmed to be infected with COVID-19 and the locations they've visited. The intention is to try and identify the time and place that the virus may have been transmitted, and to determine whether these cases are part of a common cluster or are unrelated. This can be important in understanding whether the community spread is reasonably well contained or out of control. The data in this layer comes from information published online by the Singapore Ministry of Health, following interviews with the confirmed cases. Each record represents a place visited by the person, while either asymptomatic, confirmed to have the virus, recovered from the virus, or symptomatic. For this analysis, I've removed the records representing people located in hospitals because I'm looking for those possible contacts that occurred prior to hospitalization. In order to do this type of analysis, some key fields are required. Here we have a field representing the case or the patient, a field indicating the status, the place that they visited, and also the time. In this case, we have a start time and an end time for each of these records, but there may just be a single time field. It is really important to understand how this data is being recorded. So let's take a look at case number 1. We can see that they were recorded to be at the Shangri-La Hotel on Sentosa, and that happened for 2 full days. 1 day while asymptomatic, and then 1 full day while symptomatic. Now, in reality, it's likely that they did venture outside the hotel during that time, but this is what we have in the data. For case number 2, there are actually 4 separate records and 4 different locations recorded. We can see from the start time and the end time that they're all exactly the same. So obviously this can't be correct, but this is how the data is recorded, at least in this publicly available version. Hopefully some more granular and accurate data is available, but this is still useful for us. It's just very important to understand how it is recorded and consequently what sort of conclusions you can and can't draw. This is a time-enabled data set, so let's go ahead and make sure that that is actually enabled. In the time properties, you can specify whether you have a single field or, as in our case, you have a start time and an end time. And then once that has been applied, we can start to use our time slider to play back this information over time. So now we see where those cases have appeared in Singapore, and we can play them back and see the locations visited over the last 2 months. But to take this analysis further, I want to understand if these different cases are related to one another, firstly by determining if any of them have visited the same place. And to do that, we'll create a link chart. When creating a link chart, we need to identify at least 2 different node sets or types of entities to link. The first node set here will be the case, which comes from our data set. The node field is the case string, and I'm also going to use that for the label. We want all records for an individual case to render as 1. And as the cases themselves do not define a location, I'll specify that this is a non-spatial entity. The second node is going to represent the locations. Once again, coming from the same data. This time we're going to select place as the node field and also the label. This time the location obviously is representing a specific place on the ground, so I'll leave this box unticked. Now before linking these together, I'm going to go ahead and change some of the symbology to make it easier to understand. So for the locations, I'm going to choose a symbol that really represents a place. So I'll take a building symbol and also make that a bit larger. While here, I'll turn on the label and also turn on the labels for the cases. So if I now hit apply, that's going to plot all of those different nodes onto the link chart. If I zoom in, you can see here all of the different cases and all of the different locations that they've visited. Now, obviously, we haven't linked them together yet, so that's the next step. We can create the link set, and this is going to be called location to case, starting from my location as the source node and case as the target node. And here that common identifier field is the case string. So once that's applied, all of those different entities or nodes are now linked together. We have the option to change the format or the layout of these charts too. So depending on what your data is, you could choose any of these particular layouts. For this one, the organic layout seems to work the best. So now when we zoom in and look at these clusters a little more closely, we can start to understand the linkages. For example, here we can see the 5 different people who visited Yong Tai Hung. One of them was case 19. They also visited Jalan Bukit Merah, as did case 21, case 28, and case 27. Case 27 also went on to visit Bio Crescent Market and Food Centre, as well as Tiong Bahru Market and Tiong Bahru Plaza. So we can start to get an understanding of how people have been spreading the virus throughout Singapore. One of the really nice features is that the link chart and the map are dynamically linked together. So if I go ahead and select some of the records in the link chart, for example, the corresponding records are also going to be selected and highlighted here in my map view. We can also identify the possible pathways between different cases. So let's go and have a look at the possible pathways between case number 12 here and also case number 151. So to do this, I'm going to use the All Parts tool. I'm going to select case number 12 as my source, and then zooming back into case 151, that will be the target. And once I remove the directionality, we can see that all the possible pathways between those cases have been highlighted in the link chart. And for example, I can see that there are 3 possible cases that could have come to the Grace Assembly of God and then passed the virus to case 66, who may have then passed the virus to case 151 later at Mei Hwan Drive. But common location is not enough to determine whether cases are linked. They also need to be temporally coincident, or in other words, people need to be in the same place at the same time. So to understand the temporal aspect of the data, we're going to use timelines. To start with, I'm going to focus on the cluster here related to Changi Airport. We can see that there's about 11 people associated with this one location. But my question now is, were they there at the same time? Was it actually possible for these people to transmit the virus to each other? To create my timeline, I'm going to add my layer and then use my cases as my category and display field. And then when I hit apply, you see that all of those individual cases have been plotted onto the timeline. Up the top, we can see the different dates. Here we see all the individual cases, and the blue line is representing the start and end date of each of the records. Just as before, I can come and select features in my timeline, and they will also select in the map and in the link chart. However, in my timeline, I have a lot of features on top of each other. So you can see that I've selected a lot of different features that I might not be interested in. And so in order to get down to the data that I want, I'm going to apply a definition query. I've already created a definition query for Changi Airport. Once I apply that, you can see that I'm now just dealing with a small number of cases. I do still have some cases on top of each other here, so I want to break this out into the different categories. In this case, the different cases. So now what I can see is all of the individual cases and the times that they were reported to be at Changi Airport. So the data is telling me that cases 13 and 26 were at Changi Airport between the 20th and the 27th of January. It seems that these records are not very accurate, but given what we have, we might say it's possible that these two cases are linked. But then looking at the next case, there's a minimum of 2 days between these records. So while these records may have a sufficient overlap to be linked, it's very unlikely that they are linked to cases 13 and 26. And then looking further ahead, you could say that it's unlikely that any of the remaining cases are related to each other. But if we look at another case, the picture is very different. This time I'm going to apply a definition query for Safra Jurong. Now when these cases are all plotted on the timeline, what we see is that they are all lining up exactly on top of each other, both in time and place. So if I select these records on my timeline, I can see that represented in a single place here on my map. And I can also see those records selected here in my link chart. And using this analysis, we could say that it's much more likely that these cases are linked to one another. So using the link charts and the timelines in ArcGIS Pro for Intelligence, we've been able to determine possible times and places for the transmission of the virus between individuals. This is important information to help governments understand the spread of COVID-19 in the community and to apply appropriate policy decisions.